Hi. So let's look at how you perform the delta to y transformation as well as from y to delta. Okay, so this comes about when you have a circuit and there might be a portion of the circuit that might require you to perform a delta to y transformation in order for you to simplify the circuit. Okay, and actually the delta to y transformation is the most common case. Okay, but we also do the y to delta transformation just in case you come across a question that requires you to do so. And what we have here, these like this can be resistance, it can be inductance, as well as it can be capacitance. But in the case where you have, let's say it's capacitance or inductance, you first of all have to find the impedance. Okay, we'll go through that part in a later video. We're just trying to focus on how we do the transformation. Okay, so the first one that I have here, which I might indicate as my A, this is the delta. Then as my B here, this is my Y. So first of all, look at how we perform the delta to Y. What we have here as our A is our delta, of course, and our B is our Y. So it's a thing whereby there might be a part of a circuit where you have something, a part of a circuit that might appear like that one. It might not really look the same as like more like a triangle. Sometimes it can even be more like, let's say you have a resistor here. Okay, then you have another one here, then you don't have anything down here, then you also put another resistor here, and the circuit keeps on going like that. This here and this is one and the same thing. Okay, those two are one and the same thing. All right, so now let's look at how we perform the transformation. So what it is that we are looking for here is that I'll start by trying to show how you come up with your RA. Okay, your RA. So remember, you get everything from what, from the delta. The RA is part of the Y, but we get everything from the delta. So what you observe is that this our RA. If I were to erase these two, the our RA there is more like, this is something like this. Okay, you can draw it inside there just for simplicity's purposes and understanding. Okay, then another one there like that. Okay, so what we have here, that is our RA. We have our RB and our RC there. Okay, so what you observe is that your RA is in between R1 and R2. Okay, R1, I mean, we have your R1 here and your R2. So for you to write the formula that you're going to use to find your RA, you're going to say your RA your is equals to your R1 multiplied by your R2. Okay, multiplied by your R2, and that will be divided by the sum of all the resistance, if that is resistance, which is your R1 plus your R2 plus your R3. Okay, that's simply how you find it, and you do the same thing for RB. You observe that RB is in between R2 and R3 there. Okay, so you're going to say that is your R2 multiplied by your R3 divide by everything there, that is your R1 plus your R2 plus your R3. Actually, what you can do here is that the first thing that you can do is just to find the sum of all of them, so that as you'll be writing, you won't be if you're finding all of them, you won't be wasting your time to write these over and over again. You can just write the actual value. Okay, so now what about the last one, which is RC? So RC is the same as well. RC, you observe that it's in between R1 and what, and R3. So you say R1 times your R3 divide by what, divide by your R1 plus your R2 plus your R3 there. So this is how you perform the delta to Y transformation. Meaning you're going to have your RA, RB, and what, and RC. Okay, so now, having looked at how we perform the delta to Y transformation, which is quite straightforward, and it's actually very interesting. You're going to see it when you start solving some questions. And there are some shortcuts in terms of, like, there are times when when the resistors that you are given, the value of the resistance that you are given is the same for all of them, such as it's the same for R1, R2, and R3. There's a trick that you can, there's more like a shortcut that you can use instead of you going about writing those formulas, and we'll see that when you start solving some questions. Okay, so now let's look at how we perform the y back to delta. Okay, so this I'll just try to write, it's more like, let's say here we write it like that, then I write another one there. Okay, I think I can just make it solid. It's okay since the colors are different. So you observe to say this circuit that I'm drawing outside, it's a what? It's a delta circuit. Okay, so here it's more like here we have our R1, here we have our R2, and here we have our what? We have our R3 there. So now the question is, we will start with R1. How do we come up with our R1? And we want to come up with our R1 with the data that you're going to be getting from what, I mean, the data that you have from the on the what, on the Y circuit. So what you observe here is that this R1 is opposite to what, to RB. Okay, is opposite to RB. So what you do is that you're going to say RB multiplied by RC. Okay, follow me step by step here. You're going to say your RB multiplied by what, your RC, plus, then your RC, okay, your RC multiplied by your RA, plus your RA multiplied by what, your RB, divide by RB, the one that is opposite what, the one that is opposite R1. Okay, so you observe to say I observe to say my R1 is opposite RB. Then I start moving in, like, in in a clockwise direction, by multiplying RB times RC, RC times RA times RB, just like that, until I finish all of them. Then I divide by this particular one. Okay, so you do the same thing to the other ones. We can say that would be R2. Our R2 is going to be equals to, what is opposite R2 is RC, so we can say it's RC multiplied by RA, okay, plus RA multiplied by RB, plus RB multiplied by RC, divide by RC itself, because that's the one that is opposite R2. So we go to the last one, which is R3. R3 is going to be equals to, what is opposite is RA, so we're going to say RA multiplied by RB, plus RB multiplied by RC, plus RC multiplied by RA there, divide by what, that would be divided by RA. And that is how you perform the Y back to delta, meaning you would have your what, your R1, your R2, and your what, and your R3. And this right here is how you perform from delta to Y, which is a very, very important tool that you need to know when you're solving questions on on circuit. And we are going to see in a short while as we solve one of the questions that required us to do the delta to Y transformation. And it's not every time when the question is going to specify to say do the delta to Y transformation, so that you perhaps maybe find the source current. Sometimes you just have to reason on your own when you look at the circuit, because the delta to Y transformation is for the sole purpose of making the circuit to be much simpler to work with, compared to when it's appearing complicated. Okay, so that's basically what we were looking at in this video. And in the next video, we'll try to look at a question so that at least we'll try to make sense out of what we have understood in this video. Thank you very much for watching.